Hello everyone, my name is Andrew Lee. I'm from Gamma Technologies, and today I'll be talking about an exciting new offering, which is our GT Suite on-demand cloud solution. To give you a brief peek at the agenda, I'll be starting with some background on distributed computing in GT Suite, followed by an introduction to our on-demand cloud solution, where I'll answer some questions like why use cloud, what are some common use cases, and how does it work, both from the end user and administrator perspective. So without further ado, we'll go into some background on distributed computing. For those of you who are familiar with GT models, you already know that it is quite common for models to be split by operating conditions into what we call cases in case setup. These operating conditions might include variables like engine speed, temperatures, battery state of charge, and so on. Now, when we go to run a simulation, there are a few simulation types that are available to us, the first of which is the local serial solver. This runs on your local machine, and with this simulation type, each case is sent to the solver in sequence, one after another. As an example here, if we assume that each case of this simulation takes 5 minutes to run, 8 cases multiplied by 5 minutes gives us a 40-minute runtime. Now let's say that we want to speed up the runtime of the simulation. The next option we have available is local distributed. This option still runs on our local machine, but if, for example, we had a quad-core CPU in our computer, we would have the ability to split up the cases of our model across these 4 cores and run them in parallel. Going back to our example, if we split the 8 cases across 4 cores, it would run in 10 minutes instead of the 40 minutes using the local serial solver. If we take this one step further, the next option is a distributed cluster. This is typically a server or high-performance computing cluster found on premises at your organization, and typically has many more cores available for running simulations. Assuming we have at least 8 cores available, we could run all of these cases in parallel, so this entire simulation would complete within just 5 minutes. This distributed solution works well for speeding up simulations and has been available for many years. However, as simulations become larger and more complex, and as the user base increases, we have seen a growing demand for moving these types of simulations from on-premises clusters to the cloud. And we are proud to announce that this is now possible with our new on-demand cloud solution. So why use cloud? The first and most common reason is getting results faster. With usage tracked by time instead of solver instances, this means there are no licensing limits to how many simulations can occur at the same time. This means more cases can be solved in parallel, and there is less queuing overall. So even large, complex simulations can be completed in less time. The second reason is elastic burst computing capabilities. Our on-demand cloud solution scales compute resources dynamically based on load, which provides a balance of performance while minimizing wasted hardware resources. This can be particularly valuable if you sometimes have short bursts of high simulation activity, like during occasional large design of experiments, urgent projects, or even just seasonal variations in simulation needs. Lastly, we have accessibility and reliability. This solution reduces the need to set up and maintain costly hardware on premises, and can bring the power of high-performance computing to all organizations, including smaller ones that in the past may not have had the resources or IT expertise to maintain their own compute clusters. From a more practical perspective, there are some common use cases we have heard from many of our customers that our on-demand cloud solution seeks to address. The first one is occasional large design studies. These might be extremely large design of experiments or optimization studies that occur periodically during development, particularly early on. These types of studies create a huge demand for a lot of compute resources, but are only needed for a short period of time, which is where the burst capability of cloud can be most valuable. Another use case is urgent projects. These might stem from things like last-minute design changes or a component failure in the field, where an immediate root cause analysis is required and getting simulation results quickly is critical. And lastly, just general variations in simulation needs throughout the year. We know that the demand for simulation can fluctuate depending on where you are in the product development cycle, which leads to periods of high peak usage and periods of lower baseline usage. This is another area where our on-demand cloud solution can help by smoothing out the peaks and valleys. As an example, we can consider a design of experiment study that might be performed early on in the development process. Let's say that we want to look at 8,000 DOE experiments at 5 different operating points, which gives us a total of 40,000 simulation cases. Now, this may seem like a lot, but we have been seeing that studies like this are becoming increasingly common, as it can be an efficient way to explore the design space during initial product development. Let's assume this model is moderately complex and takes approximately 3 minutes to complete each case. Now let's start by looking at how long this would take to run on a local serial solver. This allows us to run one case at a time, so with 40,000 cases and 3 minutes per case, this comes out to 120,000 minutes or 2,000 core hours of simulation time. This translates to 2,000 actual hours of runtime when running this model serially. This is approximately 83 days, or just under 3 months of time, which would make this type of study infeasible using just one solver. Next, let's look at an on-premises distributed cluster. For this example, we can assume we have 40 cores and solver licenses available to us, which would be fairly typical for a small to medium-sized organization. We have the same 40,000 cases and 3 minutes per case, but in addition, running distributed adds a little bit of overhead to merge all the results back together into one file once the simulation is completed. For a simulation this size, this would add on the order of about 30 minutes, giving us a total of 2,500 core hours to run undistributed. However, since we can now split this into 40 cores in parallel, this option takes 50.5 hours to complete, or just over 2 days, which makes this much more feasible to, say, run this job over a weekend. Lastly, let's look at the on-demand cloud solution, where things get really interesting. Let's assume that we have 800 cores available to us in the cloud. Since we're not limited by solver licenses, and we can easily scale cloud hardware up and down as needed, this is a fairly realistic number we would expect to see for this type of study. Again, we have the same 40,000 cases, 3 minutes per case, and 30 minutes of overhead for merging results, giving us the same 2,500 core hours as the on-premises cluster. But with 800 cores, we can expect the simulation to complete in about 3 hours. So you can really start to see the value of cloud computing here, as you can take a simulation that used to take several days to complete, and not only set it up, but also run it and analyze the results all within the same working day. So how does this all work? Well, GT provides a complete platform via a partnership with ParallelWorks, which is a cloud solution provider. The service includes all of the software images for GT Suite and the distributed service, which we deploy to cloud hardware on your behalf. We use dedicated hardware and license servers for each customer, with unlimited solver licenses included. Jobs are then submitted to the distributed cluster in the cloud by the end users, same as they would be on premises. All usage is tracked by time or core hours, so there is no license limit on number of concurrent solver instances. Lastly, the platform takes care of automatic scaling of compute resources based on the current demand. This is what is being shown in the animation at the bottom of the screen. You can see the number of active virtual CPUs changing up and down as load changes, which helps balance performance against minimizing cloud hardware costs. As far as the cloud hardware providers go, you can either opt for GT to provide hardware as part of the package, in which case we use the Google Cloud Platform, or if you already have your own cloud hardware, we can work with you to set up our solution on Google Cloud, Amazon AWS, or Microsoft Azure. One of the beauties of our new cloud offering is that the end user experience is virtually unchanged from that of an on-premises distributed cluster. The user clicks the Run button in GTEs as they normally would, and in the Run Simulation Wizard, they would simply point to the IP address of the cloud scheduler instead of the one on premises. From there, everything else operates identically. One other thing to note is that while the on-demand cloud solution is a new offering, we are able to support all versions going back to version 2018 and newer, which means that you do not necessarily need to update to the latest version to access this feature. For those of you familiar with our distributed queue interface, you'll find that the experience is again identical to running distributed locally, except that you are pointing to an IP address in the cloud. All of the same job management tools are available, and you can still see all of the details of each individual packet as well as the solver outputs. From an administrator perspective, ParallelWorks provides a web portal that can be used to see live usage and core hour entitlements. An administrator can also set hard limits on the minimum and maximum number of cloud resources that can be provisioned at a given time. And as mentioned before, the compute nodes themselves will respond automatically based on the current load and demand. And as before, administrators have access to the web interface on the GT side for viewing current distributed computing status, managing clients, and running jobs. In summary, our new on-demand cloud solution can provide faster results on large and complex models. It allows for scalable resources to meet fluctuating needs while having efficient and hands-off management of cloud hardware, and provides accessibility to high-performance computing to all organizations, big and small. If you have any questions or want to learn more about our on-demand cloud solution, please contact your account representative or email support@gtisoft.com. Thank you.